For those of you doing electrodynamics, you may have come across some equations that may look a bit confusing. Now, the equations that I'm looking at, or I'm referring to rather, are I RMS is equal to I max divided by square root 2. V RMS is equal to V max divided by square root 2. And then P average is equal to I RMS times V RMS. Now, in a quick video, I just wanted to show you guys where this comes from. Well, there's actually a few ways, but I just wanted to show you where it comes from and why it's necessary. All right, so let's take a look at an alternating current. So if we have a graph for alternating current, and if you've done electrodynamics, you know what I'm talking about. Alternating current is current that changes direction. So it looks kind of like a sine graph like this. So current on the y-axis, time on the x-axis. Now the current will fluctuate. It's going to fluctuate from 0 up to a maximum, let's call that I max, and then up to 0 again, and then it's going to go to minus I max, and then it's going to go back to 0. Now, for the purpose of this example, let's set the I max to some value. I think let's set it to, let's go 2 amperes. Then this is going to be 2 amperes. Well, negative 2. Now, for AC current, you'll also get AC voltage. So the graph of voltage will also look like this. It will also look like a sine graph. So it'll go like this, and down, and back here. So voltage, time, here you have a V max, here you will have a minus V max. For the purpose of this example, let's set the V max to 20. So that's going to be 20, and this will be negative 20. Now the issue is, how do we do calculations using AC? How does it work? What value are we going to be using? Because it's fluctuating all the time. So that's why we need an RMS value. An RMS value is mean. It is kind of like an average, but it's not actually the average. Now, the reason why we have to use these equations for RMS is because if you look at these examples or look at these graphs, if we had to calculate the average for these graphs, look at what happens. So if I wanted to calculate what is the average current here, we'll say that the average current, I average, is going to equal the I max plus, well, the minus I max over 2. In this case, we're going to have 20. Well, sorry, it's 2. We said it was 2. So 2 minus 2 over 0, the average current is going to be 0. Similarly, if we did the same thing for voltage, you're going to get V average, and that's going to be 20 minus 20 divided by 2, and that's 0. And so clearly that's not correct. So there has to be another way. And so what scientists and mathematicians, physicists, whoever they are, what they've come up with is we got to look at power. Now, the reason why we look at power, you'll see why now. Let me take this away. Because we know, remember that power is equal to I times V. Now, if we had to multiply these graphs together, let's look at how the graph for power is going to look. So if I take this value, 0 times 0, it's going to be 0. If I take the I max and I multiply by the V max, that's 2 times 20, that's going to give me 40. So it's going to go up to 40. Then here, this point, 0 times 0, it's going to give me 0. But now look what happens. Here we have negative 2 times negative 20. that's going to give me positive value. That's going to give me positive 40 and then back to 0. And so my power graph is going to look like this. And so now we can calculate the average power. And using that, we can get the RMS current or the RMS voltage. So here we can calculate the power. Let this be P max, and this is going to be P minimum. So we'll say that the average power is going to equal P max plus P minimum over 2. Now P max in this case is 40 plus P minimum is 0 divided by 2. And so the average power is going to be 20 watts. Now how do we use this to derive the RMS equations? So to do that, we'll look at our average power formula. So P average, we can write it as P max plus 0, because the minimum is 0, divided by 2. Now, we know that P is equal to I times V. So P max must equal I max times V max. And we know that to be true because that's how we got it, I max times V max. So here we'll just write I max times V max divided by 2. Now we want to separate this. We want to separate this into 2 fractions. And so to separate that 2 in the denominator, we need to think about how can we get 2 if we multiply. So watch this. The square root of 2 times the square root of 2 is equal to 2. So those of you who are keen-eyed, you'll probably see what I'm talking about now. So I max divided by square root 2 times V max over square root 2 is going to be my average power. Now, the I max over 2 or over square root 2 times V max over square root 2 is not the average voltage or the average current. It is the RMS. So P average is equal to I RMS times V RMS. And so this is how we get the equation that I RMS is equal to I max over square root 2. And it's also how we get the equation that V RMS is equal to V max over square root 2. And as a consequence, we get the last equation, which is P average is equal to I RMS times V RMS.